These video notes are going to be about exponential transformations. I am going to review with you just a second what you already have learned about exponential graphs. We have looked at graphs and looked at their graphs and determined if they were increasing and decreasing or decreasing. These examples that we have right here, the ones that are in blue, you can see as I move from left to right, those blue graphs are increasing in their y values. And it was a combination of their b value and the sign of their a value that determined whether they were increasing or decreasing. And the red graphs right here are both considered decreasing graphs. So that's a previous video. We've looked at A values and B values, how it behaves on the graph, increasing or decreasing. We have also looked at equations to determine if we have growth or decay. You can see that this equation right here, the B value, the base of the exponent, is a number that's bigger than 1. And since it's a number that's bigger than 1, we have exponential growth. And then because we have a b value right here, that's a number that's between 0 and 1, we have exponential decay. I do want to point out, just in case I didn't make it clear enough in previous videos, that growth and decay is only evaluated when our a value is positive. That's going to be a condition, because we know what happens when we have negative a values. The graph gets flipped upside down, and so that changes whether you have whether it's growth or decay. So the only time I'm going to ask you questions about growth and decay, where you look at the sign of the value of your b function, will be when the a values are already positive or only positive. Okay, so these are pieces of information that you've already learned. Of course, on all of these, we learned how to tell what the domain was, what the range is, what the end behavior is, what the asymptote is. All of those things are things that you have already learned, and we're going to continue to do those as we move on to this set of this piece of information. Now, transformations for the state of Texas, the state of Texas says that we only learn transformations when our b value is either a 2, a 10, or an e. And for those of you who have forgotten, e is an irrational number similar to pi, and it has a value where pi is a little bit bigger than 3, e is a little bit smaller than 3. I think we can see, if we run to Desmos real quick, we can see that e is a value that is, just type in e, there it is, a little bit smaller than 3, 2.718. Okay, so the state of Texas says that in terms of transformations, we only have to do transformations for these 3. So these 3 are considered our parent function. Okay, now we will be having exponentials that have other values of b, but I won't be asking you questions about transformations on those. I will only ask you transformations when the base of the exponent is either 2, 10, or e. So some parent function facts. We've already learned this. I'll go over. Supposed to slide over the domain. When you have one of these 3 parent functions, the domain is going to be all real numbers. And before I forget it, when you have this parent function that I have listed right here, that parent function does have an a, b, and a c value. The a is right here, and it's a 1. We're multiplying 1 times that b number. The c is right up there. It's actually a -0. And then the d value is actually right there, and that's pretty bad. So let me erase all of those again. You do have an a, b, and a c. When we have these parent functions, the a is just a 1. In other words, there's a 1 right there There's a 1 right there. There's a 1 right there. So the A value is 1. The C value, we're taking away 0 from that X value, and we're adding 0 to the end. So this is, these 3 values right here are the values that, the parameters that we're going to change to cause transformations. And the parent function still has those parameters. It's just A is a 1, C is 0, and D is 0. So the domain is always going to be all real numbers. And when we change something about it, whether it's we change the A, we change the C, or we change the D, that does not change your domain. Your domain will always be all real numbers. Your range for the parent functions is going to be 0 because on the here's the y-axis. We're down here. This is the x-axis, but my y values we talked about last time, having an asymptote. That x-axis is our asymptote. So that means that it never touches 0, but it goes really, really, really close to 0. So my range is going to start at 0, but it's not going to include it. That's why I have a parentheses right there, not a bracket, but it is going to go to infinity. So as I read this graph from the bottom up, and that's what we do when we do range, when we read it from the bottom up, the first y value is not exactly 0, but it's really, really close to 0, and then the y values go to infinity. Now, if you have either a negative A or a positive D, that's going to change. And I'm going to jump over to Desmos and give you an example of that real quick.